logarithm and exponential equations. These are already in your notes. And these are already in your notes. The same properties we've been focusing on the last couple videos. Solve the following for x. So we have a logarithm base 3 on the left. And we have a logarithm base 3 on the right. So what we can do is use the one-to-one property and the two parentheses will equal each other. So 5x minus 1 equals x plus 7. Now you just solve it like you'd solve a regular linear equation. So we'll add 1 to both sides. So we're left with 5x equals x plus 8. Then we'll subtract x from both sides. So we get 4x equals 8. And then divide both sides by 4. And we get 2. Here's a second example. Now we can't use the one-to-one property because they're not equal to each other, but we can combine these two logarithms together. We have a plus symbol. So if we go back a couple slides here, if we have addition, we can convert it back to one logarithm by multiplication. So I have a logarithm base 10 of 5x times x minus 1 equals 2. So I've combined these two pieces back together with one logarithm. Remember, they have to be the same base. They're both base 10. So now I'm going to just go ahead and multiply those two things together in the purple. So I'm going to distribute 5x times x is 5x squared. And then 5x times negative 1 is negative 5x. And then I have log base 10 equals 2. Now what I want to do is I want to remove that logarithm of base 10. How do you remove a logarithm of base 10? Is you can raise both sides to its inverse. So I can multiply both sides by raising it to the 10th power. So now I have a 10 raised to the log base 10 of 5x squared minus 5x equals 10 squared. These are inverses of each other, so we're left with just 5x squared minus 5x, and then on the right we have 10 squared. Well, 10 times 10 is 100. On the right, I'm just leaving it alone. And what happens is we have a quadratic equation. How you solve a quadratic equation is you want to get it into standard form and then try and factor it. So I'm going to bring this 100 over to the left-hand side by subtracting 100, and I'm going to try and factor it. Number one rule of factoring is to take out the GCF. So the GCF is 5. So I'm left with x squared minus x minus 20. Now we look inside the parentheses. I can factor that. It's a trinomial leading coefficient of 1. So I'm going to use the chart method. What are the factors of negative 20 that add to negative 1? Well, that's negative 5 and positive 4. Now I use the zero product property. I set this equal to 0 and that equal to 0. So x minus 5 equals 0 and x plus 4 equals 0. Add 5 to both sides. Subtract 4 from both sides. Now we get two answers. Not both of these answers will be the solution to this logarithmic equation in the beginning. If I substitute negative 4 in, you can't have a negative x as part of your domain. So this doesn't exist, the negative 4. But x equals 5 is part of the domain of a logarithm. Remember, you have to have a number greater than 0. Last example, e raised to the 2x minus 3e raised to the x plus 2 equals 0. I'm going to ignore the box for right now. I'm going to go ahead and change this to e, and now notice that you have two x's. So that's the same thing as x, e to the x times e to the x. There's two of them. And then minus 3 e to the x plus 2. Now here's where I'm going to come over to this box. If I think of this as a quadratic equation, so I have a squared minus 3a plus 2. I can factor it as a trinomial. So I can use my chart method. So I say I'm going to split up my e to the x squared as e to the x and e to the x. And then I say, what are the factors of 2 that add to negative 3? Well, that is negative 2 and negative 1. Say negative 1 here. Now I set each of those factors equal to 0 and solve for x. So I have e to the x minus 2 equals 0, and e to the x minus 1 equals 0. I solve them separately, so I'm going to add 2 to both sides. And then I want to remove that e, so I'm going to take the natural log of both sides. So I'm left with x equals the natural log of 2. I'll use my calculator in a little bit. Over here, e to the x, add 1 to both sides, take the natural log of both sides, and x equals the natural log of 1. Now just take a moment, use your calculator, and see what you get. Natural log of 2 is approximately 0.693. Natural log of 1 you should know is 0, but that's okay if you don't right now. X equals 0. So there's your two answers.